Okay guys, so chapter 2, and guys, there's only 3 sections in chapter 2 that we're going to cover. So that's good. And then we'll review and take a test. So section 1, I should say, is actually not called characteristics of quadratic functions. It's called transformations, but I've got it wrong on this. So transformations of quadratic functions. Now, haven't we already talked about transformations this year? H and K and moving things and sliding and flipping. Absolutely, we've talked about them. Now, at the beginning of the year, we talked about many different types of functions. A x squared graph, which we're going to talk about in depth today. An x cubed, a square root, an absolute value. We talked about many different types of functions. Today, we're going to dive in depth to x squared. Now, when I say quadratic, that's a word that I'll throw out a lot, and I just want to clarify, that means x squared. Something squared, that's what quadratic means, okay? So our goals today are to be able to describe transformations of quadratic functions. Then we're going to be able to write transformations of quadratic functions, and then on the back I've got a couple investigation type problems. So this translated form, that is f of x, excuse me, I lied. Translated form or vertex form goes there. We kind of know it as a translated form, but if I say vertex form, it's the same exact thing. That is f of x equals, and f of x means what again?
Y equals.
Yeah, it just means y. A times x minus h plus k. Now that should look familiar. Okay, what's this a value do in front? Easton, do you remember?
Makes it smaller or bigger.
Oh, so what'd you say?
Makes it smaller or bigger.
Smaller, bigger. Can you elaborate on that just a little bit?
Less than.
More than that.
I don't know if I like smaller or bigger.
Wider, larger,
I like
wider.
skinnier or wide. Okay, it's going to make it skinny or wide.
Really small.
Yeah, I should have made those lines a little bit bigger for you. Now, I think Ralphie and Easton started to say, you know, if it's greater than 1, what's it going to be? Skinnier or wider?
Skinnier.
Skinnier. So if it's 2 or 3 or 4, it's going to be skinny. If it is like 1/2 or 3/4 or 1/3 or 1/12, some number between 0 and 1, it's going to be wider. Okay, what's our h value do?
Moves it left and right.
Yeah, left and right. It shifts it or slides it or moves it left or right. And what's the main thing we need to remember about our h value? It is a liar. And our k value?
Up and down.
Up and down. I'll say up or down. Okay, so a couple more questions here. It says, what will make the graph flip upside down or over the x-axis? Negative where, though?
Inside.
Which one, though?
Outside. Outside.
The negative needs to be outside in front of the function. So that's kind of how we note that. If I wanted to make like an example, I could do like f of x equals -2 times x plus 4. I'm just making this up. The negative sign is way out in front. That flips it over the x, so instead of opening up, a parabola opening up, it opens down. I just ruined a question coming up. It says, what will make the graph flip sideways, left and right? Inside. So that means if the negative is inside the function right in front of x. So for example, it could be f of x equals, we'll just do -x minus 3 plus 1. I'm just making stuff up there. Well, the negative is in front of x inside the parentheses, so that's going to flip it sideways. Now, the name of a quadratic graph, I just said it, parabola. Okay, and the vertex would be a new term. Vertex in algebra means the highest or lowest point on the graph. Okay? And the vertex is going to be the point H, comma, K. Most of that should be reviewed to some extent. Okay, so here we go. Example 1, it says name the transformation of f of x. And actually, I want to stop for a second. Anyone? So if I go right here, I want to go to a clean page here. Guys, you can just watch this. Okay? You guys can just watch this. I want to investigate a little bit. Why does the graph of x squared look like a parabola? Okay? And here's why. We're going to make an x and y chart. Now, what's another name for another way to identify y? Oh, f of x, I agree with output, I agree with range, but we're going to make an x and f of x chart here. Now that's just an x and y. If you want to call that x and y, you surely can do that. Now I had some questions in the other class that said, why are we using f of x? Well, the further you get along in math, the less you'll see y, the more you'll see f of x. It's just how it is. And I had someone say, well, why don't we start with f of x? Why do we even start with y? And I said, that's a really good question. I can't answer that. So we're going to look at f of x equals x squared and kind of look into the graph of it and what it looks like. Now, here's what we're going to do. We're going to use these 5 points for our x values. Okay, so I'm going to plug in. I'm going to start with 0. If I plug 0 in for x here, what's 0 squared? 0. That means the point 0, 0 is on the graph. Okay? What's 1 squared? 1. So that's the point 1, 1. That is on the graph. What's 2 squared? 4. 2 times 2 is 4. So that means the point 2, 4 is on the graph. 2, 3, 4. Okay? Exciting stuff, I know. Now, what's negative 1 squared? That's positive 1. So the point negative 1, 1 is on the graph. Negative 1 for my x, 1 for my y. That's on the graph. What's negative 2 squared? 4. Any number squared is positive. So that means negative 2, 4 is on the graph. Now, what's 3 squared? 9. So I'm all the way up here at 9. What's negative 3 squared? 9. I'm all the way up there. I think we get the idea of why it looks like that. I never showed us that. I just said, hey, it's a parabola. Okay? Well, that's why. And we're going to get a little bit more in depth as far as being more accurate with drawing our parabolas than we have in previous chapters. A couple things about parabolas. This should be somewhat of a rounded corner there. It shouldn't be a V. Secondly, it should never look like this. It's always going to get a little bit wider. Okay, a little bit wider. Okay, here we go. Going back up to example 2. First says name the transformation. So, Luke Johnson, what's gonna happen here? What shifts, flips, transformations are gonna occur here?
The x plus 5 squared.
What's that gonna do?
It's gonna.
Jaden, can you have them out? What's this plus 5 gonna do?
Move it left or right.
Which way, Trayla? Left or right? It's going to go left. Remember, it's opposite, so it's going to go left 5. So of comparing to the parent function of just x squared, this is going to be left 5 units. Write that down. What's this minus 1 going to do, Ralphie?
It's going to go down.
I'm sorry, say it again.
It's going to go down.
Down 1. 5 is our h value, negative 1 is our k value here. So here we go. And then I'm going to graph the function. So I'm going to go 1, 2, 3, 4, 5 units left, 1 unit down. And previously, what we would do is we just graph a parabola. But what I want to do is I want to get more accurate. So don't graph the parabola. I want to get more accurate. I'm going to make an x and f of x table. Okay? Now, I want you to understand something. If I were to plug in -5 for my x value, if I were to plug in -5 here, what's -5 plus 5? 0. What's 0 squared? 0. What's 0 minus 1? -1. That's why when I type in, or when I input -5, I get -1. That's why we get that point there. Okay? Now, we want to plug in a couple more points. So what I'm going to do is I'm going to go to the right or left 1 unit of that point and pick that x value. So I'm going to go to -4. Now, why did I go -4 instead of -6? Well, that's because -4 is a smaller number, maybe a little bit easier to work with. Okay? So I'm going to plug -4 into my function. What's -4 plus 5?
1.
That's 1. What's 1 squared? 1. What's 1 minus 1? 0. So when I plug in -4 into the function, I get 0. So that means the point -4, 0 is on the graph. Okay? The nice thing about parabolas is that they are symmetrical. So there is an axis of symmetry here. Axis of symmetry, line of symmetry. So if I have this point here, -4, 0, I'm also going to have this point here, -6, 0, because it's symmetrical about that line. So that's kind of handy. Now, when we graph parabolas this chapter, guys, I need 5 points. Okay? I've got 3 of them so far. I need to plug in another x value. What x value should we plug in here?
-3.
Yeah, -3. So if I plug in -3, what's -3 plus 5?
2.
2. What's 2 squared? 4. What's 4 minus 1? 3. So the point -3, 3 is on the graph. I can then reflect that point, as long as it doesn't disappear. And there we are. And there's my parabola. I'll say again, we need 5 points. Need 5 points. If you make an x and y table like we did right here, guys, I want you to include that in your work so when it's test time, I can see what points you're getting. Are there any questions about that one? Okay, moving on to the next one. First, let's name the transformations.
It's going to flip.
Okay, why do you say it's going to flip, Peyton?
There's a negative.
There's a negative. Is the negative inside the function or outside the function?
It's inside. It's definitely outside.
Uh-oh, you guys are disagreeing. Do we see any parentheses here?
No, inside.
So it'd be outside. So isn't the negative way out in front? So that would mean it's going to reflect over our x-axis. Okay, so I would agree. It's, instead of opening up, it's going to open down. So let's write that. Let's reflect over x-axis. What's this 4 going to do?
Skinny.
It's going to make it skinny. And the 3,
Up 3.
3 is our Ka value, which is at the end, so it's going to move it up 3 units. So I'm going to put up 3 here. Okay? So let's plot the vertex. We said is it going to go left or right? No, it's going to stay on our y-axis, but now it's going to go up 3 units. So I'm going to go up 1, 2, 3 units. Again, it's not going left or right. I lied. I need to go back here. Okay, the part I says then graph the function and and name the vertex. Identify the vertex here on this first example. What's the vertex here?
5, -1, -5, -1.
Yeah, it's this point right here. It's -5, -1. That's the vertex. It's that point right there, the highest or lowest point on the graph. Now, does this one have a highest point on the graph? It's going to keep going forever and ever, isn't it? Okay, so over here, what's the vertex going to be? We'll do that later. We'll do it after we graph. We'll do it after we graph. So what I'm going to do is I'm going to make an x and f of x chart. X and y table. Well, what point do you think we should plug in?
2, 1.
I like 1. Okay, so I'm going to plug 1 in here. Guys, help me out. Do I square 1 first, or do I times it by -4?
No, F1 at first.
We square, right? Please excuse parentheses exponents. Okay, so what's 1 squared? 1. What's 1 times -4? -4 plus 3 is -1. So when I plug in 1, I get -1. So here we go. 1, -1 is on the graph. Now I can mirror that over, because my axis of symmetry lies on the y-axis. It disappeared. That'll happen. Now, I think we can already see that this is going to be skinnier, like we had said. Okay? Now, let's plug in 2. So what's 2 squared?
4.
4. What's 4 times -4? -16 plus 3 is -13. Now, this will happen. When it happens, you usually go, oh my God, Mr. Cole, it's off the graph. What do I do? Well, get it as close as you can. I understand that it's off the graph, so get it as close as you can. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. And I need to go over 2 units. So maybe right there and right there. That's in the ballpark. Is it precisely perfect? No, but I think it's definitely close. Okay, that's not a very good drawing, but it's hard to do it on my computer. Questions, comments, concerns here? I guess we need to identify the vertex, don't we? The vertex is at which point, Luke Johnson?
0, 3.
0, 3 is the vertex. Great. Okay. Now here's what I'll say. A lot of people say, Mr. Cole, can't we just graph these on our graphing calculators? And the answer is yes. And we will do that later in the year. And we'll do that actually later today. But the problem is, on this test, I will have a calculator portion of the test and a non-calculator portion of the test. So we need to be able to graph these without using our graphing calculator. Here we go. Example 2, it says writing a transformed quadratic function. So it says let the graph of g of x be a vertical shrink. Vertical shrink. Now, again, I don't like that word smaller because is it skinnier or wider?
Wider. It's wider. It's a half.
Okay. Now let's just think about a ball of cookie dough. A ball of cookie dough, and I vertically shrink it. I step on it or squish it down. Does it get skinnier or wider?
Wider.
It gets wider. Okay, so a vertical shrink, okay, is like a horizontal stretch. So it's going to get wider. And a reflection in the x-axis, followed by a translation 2 units up from the parent function f of x equals x squared. It says write a rule. So we're using this parent function, and we're going to write a rule for this function called g of x. Now, it's got a vertical shrink of a half. Okay, well, what should we do with that half? Where's that going to go?
Before the x.
Great, before the x. So it's going to go in front. That's our a value. All right, and then it says a reflection in the x-axis. Easton, how are I going to write that in our function here? Great, the negative is going to go in front of the half because it's reflecting over the x-axis. Reflecting, the negative goes in half. And then followed by a translation 2 units up. So here we go, I'm going to have x, and leave some space for our h, and then our k. So what's the 2 do? Where's that go? Plus 2 at the end. Are we moving it side to side at all? We're not moving it side to side. So it's like plus 0. Now, we don't need to include the plus 0, and I forgot my squared because it is a quadratic. So let's just get rid of that 0. So if I get rid of the 0, then there's really no need for the parentheses. So I'm going to have x, I don't need parentheses, I just said that, x squared plus 2. So our function g of x is negative 1/2 x squared plus 2. And it says identify the vertex. Are we moving left and right at all? No, we're not. So it's just going to be 0, 2. Open up or open down?
Open down.
It's going to open down, right? Great. Everyone needs a graphing calculator. If you don't have one, you can use your own, or you can use one right there. So go grab one if you don't have one right now. Okay. Now, some of this is going to be new, so hang with me here. These 2 problems will take a little bit. It says the height h in feet of a water balloon can be modeled by this function. H of x, that's why it's h, because of the height. H of x equals negative 3x squared plus 24x plus 11. Now, is that in vertex form?
No.
No, this does not look like any of the other functions that we've talked about so far. And I don't want that to fool you. I don't want that to confuse you. And it says where x is the horizontal distance in feet from the launch pad. Okay, so x is the horizontal distance in feet from the launch pad, and h of x is what? The height. Okay, so here's what we're getting at. If I were to launch a balloon in the air, it's going to go like that. It's going to launch up, gravity is going to be inflicting force upon it, and it's going to get to the top, and eventually it's going to come back down. Now here's what we need to understand. Our x value represents our horizontal distance. Okay? That means if I were to plug in 1 into the function and do a bunch of math and do 1 squared is 1 times negative 3 and so on and so forth, I would get h of t, which is our height. So that means after 1 feet horizontally, it's going to be a certain amount of feet in the air. Okay? And if I want to know, hey, how high is it? If it's 2 feet horizontally, I'd plug in 2 and I would get that number. I would plug, if I want to know how high it is after, I don't know, 8, I'm just making that number up, plug 8 into the function, and that would get our height. Okay? Now, here's the thing. It says the launch pad is adjusted so that the water balloon lands exactly 9 feet away from the launch pad. So here, maybe the launch pad's here. That's about 9 feet. It's going to land 9 feet away. Write a function that models the new path of the water balloon. Okay? Here's what we're going to do. We're going to use our graphing calculator. So everyone follow along. I need everyone to hit this y equals button right here in the top left-hand corner. Raise your hand if you have never graphed with our graphing calculator before. Okay? So we're going to go ahead and we're going to type in our function, which is negative 3x plus squared plus 24x plus 11. So I'm going to type in negative 3. Guys, this is the negative button. This is the minus button. If you put in the minus button instead of the negative, it won't work. It'll say error, okay? So make sure we're hitting the negative button. Negative 3. I think I like doing the screen better. Negative 3. This is unbelievable. Quick, Peyton, tell me everything that's on the chemistry test. All right, here we go. It's working. I'm recording. We're good to go. I'm going to type in negative 3. Guys, this button right here is our X button where it says X, T. It's got a weird symbol, theta. That is our X button. So type that in, please. You guys are doing this with me. Negative 3x, and then I need to hit the squared button. And then I need to go plus 24x. 24x plus 11. Okay, there's my function. Now, you can hit the graph button, but here's understand something. People in the other math class have been using this. So they adjust their windows. So if you just hit graph, it's going to go to the window size, and you'll understand what I'm talking about here in a little bit, that they were just at. So if you want to just graph it in the standard window, you're going to hit zoom, and then 6 it says Z standard. That is just the standard window. So it'll graph it using the standard window. Okay? Does everyone have this? Does anyone not have this?
It's a big problem.
Okay, now here's the question. Does this give us a very good graph of what's going on here?
No.
It doesn't, okay? So what we can do is change the window, meaning, hey, where are we looking at? Okay, so let's think about something. Where do I need to look at? So if I think about my x values, what does x values represent again?
The horizontal distance.
The horizontal distance. Am I worried about the negative horizontal distance?
Oh, not really.
No, we're not going to shoot the water balloon backwards. So I don't need to worry about this entire part, the left part of the graph. Okay? Am I worried about where the balloon's going to travel after it goes through the ground?
No.
No. So I don't need to look where the graph is below the y-axis. Okay? So here's what we're going to do. We're going to hit window. Okay? We're going to hit window, and it gets a bunch of this stuff. Now, x min, what does that mean? That means, what's the minimum x value we want to look at?
0.
We want it to be 0. Because we don't want to look at negative horizontal distance. It doesn't help us. Okay? Now, what's our x max? Meaning, our x value is right here. Our x part of the graph. Okay? What is the highest x value we want to look at? Now, don't trust these numbers. These aren't right. I think in the problem it says we want to adjust it so it goes to 9. So let's pick 9. And actually, I'm just going to keep it at 10. 9 is close to 10. I'm just going to keep it at 10. Now, X scale, that means, hey, do you guys want to count by 1s? Or do you want to count by 2s? Or count by 5s? Usually, I don't really adjust that too often. I'm going to keep that there. Now, what's my Y min? What do I want my Y min to be? 0. Again, I'm not worried about any negative Y values because the water balloon is going to hit the ground. Okay? So I'm going to hit 0 there. And Y max, how high is this thing going to go?
9 or 0, I don't know.
We don't know. Okay? I don't know how high this is going to go. I know it's going to travel about 9 feet, which is about here from the wall. But is it going to be ceiling height, or is it going to be way, 60 feet in the air? I don't know. So I'm just gonna leave it at 10 once and just see. I don't know. And then the Y scale is counting. So now from there, I'm gonna hit graph. I've just adjusted my window. Ruh-roh. Is that very good? No. What do I need to do?
No, you gotta fix the max.
Go to my window. I needed to adjust my X max.
Oh, Y.
Y max. 10 wasn't even close, was it? So let's adjust it to,
Not 20 either.
Alyssa, you've already tried 20?
Maybe like 40.
I'm going to try 60,
Oh, okay.
because I know. If you guys don't know, you might just have to try numbers.
Oh, look at it.
Isn't that pretty?
Wow, that's crazy.
Now, notice this, guys. Notice over here how I've got these like dark lines on my y-axis. That's because my y scale is 1. If I were to go to my y scale and let's count by 10s instead of 1s, now hit graph. Now there's going to be 6 tick marks because I went to 60 rather than 60 tick marks. Does that make sense? So it just makes it a little bit neater. You don't need to do it. There's our graph. That's what it looks like.
So we draw it now?
Okay? Yeah, let's go ahead and draw that.
Yay.
And how do you get 6 tick marks?
That was so hard just for one.
Now, as we keep doing it, you'll just do it faster. It's like you're texting. When you guys start texting, you've got one.
Aw, dang it.
It's impossible. It's hard to text fast, and next thing you know, you're.
I don't think it's the same thing.
It's close.
Okay.
Okay, so let's graph this. I don't have it in front of me. Where does it start?
Okay.
Is it?
It's kind of like.
How did you get 6 tick marks?
So you go to Y scale in your window.
Okay, don't do that. Just keep it on one.
I'm going to Y scale.
Does it start like here somewhere?
Yeah, right about there. And then you just kind of go up and
But
back
what do you
down.
do? Do you go
Yep,
with
and then you
5s?
come back down.
Count by 10s.
Oh, yeah.
Okay, that's not very good. We should always label our axis, horizontal distance, and this is our height. I'm just going to put h of x because I don't have room.
What do you do?
Okay, now here's what I want you to do. Go to your graphing calculator, and I want you guys to hit the second button, which is the blue button on the top left. Hit second, then hit this table, or this button that says graph, and then above it in blue it says
Oh
table.
my gosh. Table.
Okay, now this gives us a table of values. Okay, yours is looking probably different than mine. I want everyone to go to 0. Go to 0 on our table.
It's at 5 points.
It says 0, 11. What does that mean?
That's where your point is. I think.
Vertex.
No, it's not a vertex.
Yep.
But now if I go to my graph, that means, hey, my x value is 0. Where's my x value 0? That's right here, isn't it?
Yeah.
So at 0, how high are we?
11.
At 0 horizontally feet, we're up 11 feet. What does that mean?
That's where we're starting.
What'd you say?
That's where we're starting.
Where we're starting. Where what's starting?
That's where our table can start.
No. Relative to the graph. Aren't we launching a balloon, Luke Johnson? Yeah, we're launching a balloon. So are we launching the balloon from the ground?
No.
That's
No.
where it starts at
Standing.
hand.
I told you to restart.
We're starting 11 feet in the air. So maybe we got a balloon launcher and we're on the top of a roof. Maybe we're on a ladder. Maybe we're in a tree house, the back of a pickup truck. I don't know. But we are up 11 feet when we start. Okay? Now, hang with me here. As we go, after one horizontal foot, going 1 foot horizontally, we're up 32 feet. After 2 feet, it's 47 feet in the air. 3 feet, 56. 4 feet, 59. 5 feet, 56.
Has to be 459.
Yeah, that's the highest.
Okay, the highest is 459.
That has to be it.
So we're at that vertex right
What happened
now. It
after
starts
4?
to go down.
It started to go down, right?
Gravity.
It started to go down. Gravity. Now, let's keep going here. Where does it hit the ground?
Oh, no.
In between 8 and 9.
Luke, why'd you say in between 8 and 9?
Because 8's positive, 9 goes negative.
Because Luke said at 8 it was positive, meaning it's in the air. And then at 9 it was negative, which means it's past the ground. So somewhere between 8 and 9 feet, okay, in between 8 and 9 feet, it hit the ground.
Can you figure that out or not?
Okay? Now, what's the problem ask us?
Write a function. That module's in the ground water balloon.
They want the balloon to go 9 feet. Maybe they're trying to hit their target or something. They want the balloon to go 9 feet. So they need to adjust the launch pad. So instead of being 11 feet in the air, it could be something different. Okay? So we get to 9 feet. Now understand something. What is this point right here?
When it hits the ground.
It's where it hits the ground, and that is between where?
8 and 9.
8 and 9. Now, this keeps going. Okay? The graph keeps going. Now, it's not in real life because it hits the ground, but the path, the parabola, does keep going. Now, at 9 right now, at 9, where are we?
Negative 16.
We are at negative 16. So right here on our y-axis, at 9, I'm at negative 16. So here's the question. How do I need to adjust the launch pad so it gets to 9 horizontal feet?
You should throw it further.
Now, we can't adjust how far we're throwing it because
Go down.
we're doing the
Don't you?
same parabola.
Don't you start lower maybe?
Alyssa's
I don't know.
proposing that we start lower. So basically you're saying, hey, shift it down.
Yeah, maybe, but I don't know if that'll work.
Okay? So if I shift
Or up.
it, listen. If I shift this thing down, is it going to get thrown farther
No,
or shorter?
shorter.
It's going to be thrown shorter. Because check this out, guys. The farther we go horizontally, doesn't it go further?
Mm-hmm. Yeah.
So rather than shifting it down, let's shift this thing
Up.
up. Okay? Now, how far up?
Like 1 or 2. 1 or 2, I don't know.
Not
Maybe
too far.
3.
Not too far up. But here's the question, guys.
Like
Is
16.
it this at negative 16?
Yeah.
And don't we want this point to be right here?
Maybe like 4.
Up 6.
We want to go up 16 units.
Oh.
Because that point at 9 is now at negative 16. We want it to be 9 what?
0.
We want it to be 9, 0, the point. But right now it's 9, 16. So it's 16 units too low.
So we want to start at 27.
So we need to move it up 16. Now, how do we move things on a graph going up and down?
It's your K value.
Our K value, which our K value always is at the very, very
And
end. So here's what we need to do.
So it's the same thing left.
I don't know what's going on here. Just now not working either. Just love technology. Okay, so I've got negative, I need to write this out here for the video. I've got h of x equals negative 3x squared plus 24x plus 11, and we just talked about how we need to shift the graph up 16 units, so I'm going to add 16 to that. So my new function is going to be negative 3x squared plus 24x plus 27. Questions there? Okay, I've got another one that's very similar. This one shouldn't take as long since we just did one. Okay, so let's type in this function. Hang with me, guys. I'll do another 10 minutes here, and you'll have a half hour to work. Okay, so I'm going to go to y equals, and we need to type this guy in. So I'm going to do negative 0.03
I can't get mine to add that. Okay.
x squared
Wow.
plus x plus 25. Now understand something. What's this problem entail? Is it a water balloon? No, it's water spraying from a fire hose. Do you think water spraying from a fire hose is going to go further than maybe a water balloon being launched? I would agree. So what I'm getting at here is the scale that, or the window that we just set up for this other problem, more chances than not, is not going to work for this window. Okay? Make sure you typed it in right, and I didn't, did I? What did I forget? I need everyone's eyes up here quick. I forgot negative. Here's a learning point, okay? Watch this. If I were to take my arrow over here and put, ooh, I did have a negative.
Yeah.
Perfect, it slid over. I'm going to show you this anyway. I'm going to delete that. So let's say I forgot my negative here. And if I were to go here and put the negative, it's going to replace the 0.
Basically, just retype that.
And so then I'm going to be 1 off every single time. Does that make sense? So what I can do is hit second and then hit this button, the delete button, which is INS. See how it says INS there? Oh, that's great. Second insert. That means I can now type in my negative 0.0 and I can slide it over. Now it's correct. So I'm going to hit window. Actually, I'm going to hit zoom, excuse me, zoom 6, remember, will get us to our standard window. Am I even graphing this right now? It's not even remotely close. So let's go to my window. What's my x min going to be? 0. What's my y min going to be? 0. Okay, what about my x max? Guys, I have no idea. I'm going to try 100. I mean, a fire hose can shoot a long ways. You know, I could be wrong, but I'm just going to try that. What about my y max? Now, if you're a firefighter, are you going to probably go shoot it way in the air? Probably not, because then you've got wind throwing with it. So I'm guessing it doesn't need to be as high as it does wide. So maybe I'll just try 50 there. And I'm going to hit graph. And I could be wrong. I could be right. Okay, so I see it. So how can I adjust this to get a better view? Hit window. What about my x max? If I go back to my graph, what do I know about my x max? It's right at 100 right now. Does it need to be 100?
No.
Doesn't need to be 100. It should probably be like what?
70.
70?
65.
Ooh,
Okay.
70.
And so if I hit graph now, that's a little bit better. Does it need to be, I could even go shorter.
Let's
Yeah,
go
it's
shorter.
short.
50.
Now, we don't have to get it perfect. You just have to get a general idea of what it looks like. Okay, now here's my question. Didn't I say, guys, didn't I say it's probably going to go further than it does high?
Yeah.
That almost kind of looks the same, doesn't it?
Okay.
Maybe. Understand, though, this, guys, that my x goes to 70 and my height only goes to 50. So it's not square. Does that make sense?
Yeah.
So it may be distorted based upon our window. Okay, let's understand the problem. So, if I draw a quick picture, I like pictures. I don't know why this thing is up. If I draw a quick picture, here's my fire truck. And they've got this thing up here where they're going to shoot a fire hose. Not bad, huh? Now, what's the problem? Ask us.
Try to function that models the path of the water.
Okay, it says the crew raises the ladder so the water hits the ground 10 feet farther from the fire truck. Okay, so here's my original picture. What they are going to do is they are going to raise this up. They're going to raise the ladder up, so now it's going to fall 10 feet further. Okay, let's go to my graphing calculator, because right now, how far is the water traveling now?
25 feet.
How far is the water traveling?
I don't know.
We don't know that. Let's go to our calculator. I'm going to ask this. What are they asking us again?
Write a function
Write a function to what, though?
that models the new path of the water.
The new path of the water. We're going to raise up the ladder to get it 10 feet further. Raise up the ladder to get it 10 feet further. So here we go. Second table. So at zero horizontal feet, how high is the water?
Like that.
What's that tell us, Easton? The water at 0 horizontal feet is at 25 feet in the air, meaning that's our starting point. We're starting 25 feet in the air. Okay? So after 1 horizontal feet, there we are. After 2, after 3, after 4, you can see. Is this going higher really fast or not very fast?
Not very
Not
fast.
very. I think we would agree there. When does it start going down though?
Oh, right here.
19. Oh no, 18.
No. 18's the highest point.
I disagree there.
I was just kidding. 7.
I think 17 is the highest, and then after
17.
17 feet, then it starts going down, doesn't it?
Yep.
Now, what am I looking for?
We're looking for.
I want the water to go 10 feet further. But how far is it going right now?
We don't know.
You don't know that. So what am I looking for? I don't know. Hey, how far is the water going?
So it's going 17.
When the water hits the ground, what do I know about the x and the y coordinates when the water hits the ground?
It's 0.
What's, not 0, 0.
It's something 0.
Is the x 0 or the y 0?
The
Y.
X.
When it hits the
Y
ground,
is
it should be
zero.
The height represents our
0.
y, right? We want that to be 0. So I'm looking for where in the world is our y 0. And as you can see, I'm getting closer, I'm getting closer, I'm getting closer. Oh, bingo.
big.
Up 1 mile.
So right now,
25
it's traveling 50 feet. You okay with how we got that?
Yeah.
Now I want to know, how far is it at 60? Because we want to go 10 feet further, which that is 60 feet. Or where is the water at 60 feet? And it's at negative 23.
Can you add 23 to 25?
What, Alyssa?
Add 23 to 25.
So we at 60, we're below the ground. We're at negative 23. We want that to be at 0. So how much do we have to shift the graph up?
Up 23.
23 feet. Okay? So our function then, our function is, help me out here, it's h of x equals negative 0.03 x squared, help me here,
Plus X. Plus 25.
plus x plus 25.
Plus 23.
And I need to add to that 23. So then we're going to get negative 0.03 x squared plus x plus 48. So this is our new function.